Okay, this video is going to go over something that you could possibly live your entire Unix life without even considering the fact that it exists and still survive. But we're going to go over it anyway because sometimes it's good to know some of these things. So anyway, we talked about file permissions, and I don't really have any files in this directory, so I'll just do. That's not what I wanted. So we've talked about file permissions in previous videos, and we end up with something like this: read write x, read dash x, read dash x. We talked about how to change the file permissions, but what we didn't talk about is how do these file permissions get set by default. So if I create a file, you can use the touch command to create an empty file. If I create a file, it automatically gets some file permissions, and the question is, well, how does that happen? You know, does the system just automatically set it the same thing for everybody? I don't know. Let's create one as root. So in this window, I'm running as root. In this window, I'm running as my regular user. So as root, I'm going to create a user account. And if we go back and look at those files, we got two different sets of permissions, right? My regular user gave the group right when it created the file, and my root user did not give the group right. So how is that controlled? Well, that is controlled by a thing called the Umask. If you type in the word Umask, it tells you what your Umask is currently set to. So my regular user has a Umask setting of 2, 0, 0, 0, 2. My root user has a Umask setting of 0, 0, 2, 2. So now we see what the values are, but what do those values mean? Well, these values are essentially the opposite of the file permission values. And what do I mean by that? Well, if we remember, we can set file permissions with this hex, not hex, octal number. Couldn't remember the numbering system used for that. We can set the file permission with this octal number, which we know we should hopefully remember that 755 gives us read, write, execute for the owner, read and execute for the group, and read and execute for other. And that breaks down to this binary value. We have a 1 in each of these bit positions. We have a 1, a 0, a 1 in each of these bit positions, and we have a 1, a 0, 1 in each of these bit positions. So if we look at the files again, none of these files have those settings, so that's not a very good example based on what we already see. So anyway, we'll talk about what this means as far as UMask. This is the binary of the permissions. The UMask is the opposite of that. So in this case, the UMask would be, that would be the UMask to get these settings. We have all zeros here, we have 0, 1, 0 here to go along with the 1, 0, 1, and we have 0, 1, 0 here. So if we translate that into octal, we end up with 0, 2, 2. So that gives read and execute and read and execute for the files. So that would be the UMask value to go along with that set of permissions. So you might be saying, hey Rich, I thought you said that didn't match what we had. And that's another tricky thing about Unix, Linux file permissions. This says 022, which in theory means we should be giving execute on our files. But if we look at my UMask is 022 for my root user, right? But there's no execute bits on these. Well, we'll learn this when we get to scripting, but we don't get execute by default. We have to add execute explicitly on our files. The place that X comes in is if we create a directory, we should automatically have the X on our directory. So the directory automatically got the X as we expect. The regular files will not automatically get X. So that was one example. Let me find my little text file again. There it is. Another example down here, 750. That would give theoretically read write x, read dash x, and nothing. So this is what it looks like in binary. So if we want to find out what it should be in the UMask should be, we type the opposite of that binary permissions to get the UMask, and that gives us 0, These first three go together to be 0. This is the 4-bit, not the 4-bit. 4, 2, 1. So I only have the 2. And then this is all three of them set. So that's 4 plus 2 plus 1, which gives us 7. So the Umask to end up with these permissions would be 027. So that's how it works. It might make your head hurt a little bit thinking about it, but it's the opposite of the permissions. If you want to change your Umask setting, you can do that on the fly. So for root, I might want to make my Umask 027 so that nobody can get I don't create any world readable files, which is a good practice. So I set my Umask to 027, and now if I ask what it is, it says 027. And now if I create a new file, file 3, and look at the permissions, I don't have any permissions for other. So that was more secure. This change only persists in this active session. Once I log out and log back in, then my Umask gets set back. So if you wanted to permanently change your Umask, you need it to get set every time you log in. And the best way to do that is to put it in your profile. Root, so I need to put it in roots profile. And just down at the bottom, you could basically just say Umask 027, and that will set your file creation mask at login. So exit, clear. If I become root again, and now ask my Umask. Now my Umask is 027. So, like I said, this might hurt your head right now. I just want to make sure you knew it exists and how it works. To summarize, your file will get created with the permissions as determined using the Umask when you create a new file. If you want to change what those permissions are, you need to change your Umask setting. If you want that change to persist through multiple login sessions, then you need to put that in a file that gets executed every time you log in. And for the bash shell, that would be the bash profile. So that is all I wanted to say about Umask.